What's up, GeoGebra lovers? I'm the GeoGebra guy. I'm so sorry I don't have the GeoGebra logo for my head, and I don't even own a suit. I'm just very insecure about my English, and I'll start by making these additional videos as a way to practice my English. And I don't know, maybe someday the real GeoGebra guy is going to make an appearance on the channel. But for now, you are here because you want to know the thought process behind this wiggly circular motion. Alright, as I said, you can twist some parameters here, the n, the number of wigglings, the amplitude, and it can become a flower if you twist it right. So no one taught me how to do this. That's the beauty of math. You can just create stuff if you want to. So let me walk you through my line of thought of how I coded this curve. I don't know if this has a official mathematical name, but I don't know. I just created it myself. So we have the circular motion movement. Parametric equations are r times cosine t, r times sine t, and it just makes a circle with radius r. So what we want to do is make this motion wiggle, right? Wiggle around the radius r. So I thought, alright, I just have to change r to something like r times a wiggling factor. And this wiggling factor is some number that revolves around the number 1. You know, it can revolves, it can go between, I don't know, 0.9 and 1.1, 0.8, 1.2, I don't know, anything. So I have to create a wiggling factor that oscillates around the number 1, and that's it. So what better way to wiggle than our friend, the sine function? We know that sine of anything oscillates between -1 and 1, alright? So it doesn't quite work for us yet because we want it to oscillate by a very tiny value around 1. So if we think, alright, sine oscillates between -1 and 1, but sine over 2 oscillates between -0.5 and 0.5. So we are getting there, because if we think like, oh, if I go sine over 10, it oscillates between -1/10 and 1/10. But this isn't quite what we want, right? So what we want to do is make 1 plus sine over 10. So this is gonna oscillate between 1 plus this, that is 0.9, and 1 plus 1/10, that is 1.1. So if we want to adjust this amplitude of oscillation, we just substitute this 10 here by some number, by a slider that we call a. So this is gonna oscillate between 1 plus 1 over a and 1 less 1 over a, alright? But the thing is, what do we put here on our sine function? If we put just t, the same parametric variable as our parametric curves, t oscillates between 0 and 2 pi and repeats. So we can't just put t here because it would only oscillate once between 0.9 and 1.1. But the thing is, when we take sine functions like sine of 2t, these have two oscillations when t goes from 0 to 2 pi. Because if t goes to 0 to 2 pi, 2t is going to go from 0 to 4 pi, so two oscillations. So instead of thinking, alright, sine of t, we have to think, oh, sine of nt. Because if we have like sine of 3t, this oscillates every 120 degrees. If we get like sine of 4t, this oscillates every 90 degrees, and so on. So sine of nt should be our factor. But so the variable a is gonna go from 1 to, I don't know how much you wanna less the amplitude, I don't know, my English is bad, sorry, and n is going to go from 1 to anything, any number of of oscillations you wanna do in your wiggling motion. So I don't know here, but the thing is, the step we're gonna have here is 1. N cannot be, it could be like 2.3, but it's gonna cause us some trouble. All right, so this is the factor that we are looking for: 1 plus sine nt over a, where n and a will be our sliders, our parametric, not parametric, but our parameters of oscillation. All right, so if we go back to GeoGebra, you will remember from the video, this is actually the equation I showed you. Here you go. All right, r times 1 plus sine nt over a cosine r times 1 blah, blah, blah. And the same thing goes for our point, you know, because it has to accompany, it has to lead the curve, and you can adjust n and a. So here a equals 1, you get the flower shape because you have 1 plus sine over 1, and this will oscillate between 0 and 2. So this is gonna go to the center and then to the double the value of the radius. But you can adjust a, you can adjust n. Let me just put the angle total here. So you can see as n goes upwards, it increases the amount of wiggling. You know, if you try to make n equals 1, you'll see that it's a circle. N equals 2 is like I mean I think this is 2 semicircles. I don't know what this is, but I don't know. It generates some cool curves like this. All right, and that is basically it, guys. My name is Lucas. I'm a math teacher from Brazil. As you can see, I just love teaching math. I love creating stuff on GeoGebra using math, and I am a complete GeoGebra nerd, so I have still a lot of stuff to show you, so make sure you subscribe to the channel. I have a lot of experience in 101 lessons, so I'll leave my contact down below. As you can see, English is not my first language, but I think you can understand me. I think I can teach you some things. And if you are an American student, I've had some students here in Brazil that go to an American school, so I've come in contact with HL Math, SL Math. So that's it. Subscribe to the channel or you will forget the quadratic formula.